Testing is important for embedded software. Testing is always important, but it's especially important for embedded software because debugging doesn't always work depending on your target environment. Your device may not be available. There may not even be a debugger for the target device. You can, of course, run your system on a PC and then use the debugger that's part of mbeddr. It can be connected to devices as well. There's a separate video for that. Anyway, testing is important. And so let me show you how we do this in mbeddr. We've built actually quite a bit of support. So here is a new model. I'm going to create a minimal test using the wizard, which I call test demo. It's simply a module that has a main function in it. It has one test case here. The test case is called from the main function. This special expression here tests all the test cases, or calls all the test cases. Just create a second one, T2, right? So you can use the intention include all visible test cases, then it calls both of them. And what it does is it collects the number of assertion failures, and because it's returned here, returns them back to the operating system, so you get a nice useful exit value. Okay, so let's actually implement a test case. Let's keep it simple for the time being. Int 8 x equals 10. Int 8 y equals 20. Int 8 z equals x plus y. And then assert z equals 30. Okay, rebuild. And let's open a command line and run the thing, make test. And you can see it runs this test demo test case 1. That is, of course, the module name and the test case name. Let's make it fail. Okay, 33. Let's go back here, make test, and now you can see it failed. And of course, again, you can navigate manually to the offending assert statement. It even tells you which assert statement it was. It's the one with the index 0, right? This guy. But you can also grab this output here, the console output, copy it, and paste it in the mbeddr analyze error output. Right? You paste it here, you press this button, and then you get a hyperlinked node in this tree. You can, and that's useful if you get the test output from somewhere else. But you can also run the thing directly here. So you go to the edit configurations, run configurations, create a new one, an mbeddr binary, which you probably want to call test demo. And you select the executable to run, which would be test demo. That's the one you specify in the build configuration. And once you've done that, you can run it from here, and then you get the same output, but now it's directly hyperlinked. Very nice. Okay, so now this error message doesn't tell you what Z was. It just tells you that it failed, so it probably was not 33. Now, how do you log error message? And by the way, we are going to create better assert statements in the near future with other assert equals and expected and actual and stuff. But let's say we wanted to know the value of x. We can mark the x, do a log statement. You can also do this, there's this intention, log this expression. And if you rebuild, and rerun, then you can see it gives you an output from, again, it tells you from where it comes, the module, the test case, and then the index of the log statement. It tells you y equals 20, x equals 10. And so you have a way of kind of looking into the program. So let's delete those again. Now, as I said, or maybe I didn't, things like the assert statement are not available outside of test cases. You can only do this in test cases, but you can implement arbitrary additional functions, helper, and then mark it as a test helper. And then you can call it from here, helper, and inside of that you can use the assert as well. This also works, by the way, with component runnables. So you can move some of the test code into components. Talking about components, components provide a lot of special support for testing. Let's look at an example. First of all, here is a mock component, which I talked about it in the components video, which doesn't implement an interface directly. Instead, it specifies what this component expects to see on the provided port in terms of incoming calls in a test case. And here we say we expect 5 incoming calls. The first one we expect is empty, we return true. The second one we expect the store to be called, and we assert that the TP parameter is not null. We remember TP in our field here, and then we expect another is empty, we return false, and so on and so on. So this is a way of specifying expected behavior in tests for components, extremely useful. You can then instantiate such a component, non-surprisingly, and then you can, from within a test case, you can validate it, and if it saw something else than what it described in terms of its expected behavior, then it fails. And so this is another way of expressing test behavior. Also, looking for an example here, right here, there is a test case where you can see with this dollar notation, we call the processor process runnable on the interpol component in the verification instances collection, right? It's these instances, it's this instance, and it has a processor process. Notice that in this case we call the runnable directly. We don't go through an interface. We can even do this for runnables that are kind of private, that do not have a trigger that connects it to an actual interface. This way we can call, quote, private methods without making them public, just so we can do testing. That's a very handy feature. There's also special support for testing state machines. You can always write a state machine test, for example, by just triggering an event and then checking in what state it is. But there is this special thing which simply says, I trigger this event and I expect it to be in that state. And you can have any number of these, and so you can write tests very concisely. There is other ways or other things that are interesting for testing. For example, here is something we've built where you can embed business calculation rules directly in requirements. We haven't talked about requirements yet, but the point is that here there is an interpreter running which runs tests, if you will, directly, right? So this thing here is essentially calling this calculation function. It passes in these two arguments. This is the expression that determines the value of the result, and then you can pass in actual arguments and you can see whether they calculate correctly. So there is an interpreter running here. This is of course specifically built, but you can do that so easily. And so this is also a way of enabling your users to test your application code. Another thing, final thing that I want to show is we have had the problem where we wanted to test certain hardware specific behavior on the PC where that particular hardware was not available. And so the thing is, we had a specific processor platform on which we ran certain systems, a certain software, piece of software, embedded code components, and it had special registers. And these registers were special in the sense that if you wrote to them, then a special hardware implemented calculation was triggered. So if you wrote the value 10, it didn't store 10, it did some calculation and then stored the result. Now, how can you make this testable on a PC where this special purpose register isn't available? So to make a long story short, what we did was we built a little language which allows us to specify or declare registers directly, and you can then, R2 is one of these registers, you can assign to it normally, but then you can have two ways of transforming those. You can either mark the transformation as emulated, in which case we don't actually access these registers on the PC, they don't exist. Instead, we generate a bunch of structs and simulate it. And also this assignment will be replaced by, instead of saying R2 equals 5, it would be R2 equals 5 times 1000. That is this expression that's specified here. And if you change that to real world, then we leave the code as it is, include the header file of the target platform, and we access the register directly. So what I'm saying is that you can of course build custom language extensions that make testing in your particular environment much simpler. There is one last thing I should say, almost forgot it. When we go back to our test demo here, we got all these, all this output on the console. You only get the output if in the build configuration your reporting is set to printf. mbeddr comes with a sophisticated reporting framework. Let me show you this. You can define a message list, messages, and then you can declare a message, something, oops, shouldn't type here, I should type right here, something went wrong. You can even give it an argument, some kind of information, and then an error text, and then from anywhere you can report one of these messages, right? It even tells you that it expects an argument like 1, and if you, let's rerun this and see what happens. And here you get something went wrong. Here is the error text. This output only appears actually on the console if reporting is set to printf. There is also do nothing, and you can plug in your own reporting frameworks. For example, you report to an error memory or to a serial line or whatever. The point is that the error messages that are created by the assertions, they use the same reporting mechanism. So if you don't set reporting to printf, you won't see anything. One final thing, there are two different forms of the report statement. You can put a condition here. Let's say argc. Right, you first have to specify that you want a Boolean condition. argc is not null, then this thing is only executed, or the message only comes out if argc is not null. The reason why we put this directly right here instead of wrapping it in an if statement is that you can deactivate messages, then it's an inactive message, and then there is no code being generated. So there is no overhead, not even for the if condition. So by putting the condition as part of the message raising code, you get the ability to, by deactivating it, statically remove all the overhead. Anyway, you should take a look as usual at the user guide. It explains it in some more detail. I guess this was a quick overview about testing. I hope you agree that this is quite a bit you can do, and of course you can run all these things on nightly, builds integration servers and stuff, and then get really a well-tested system.